Hi, sweetie. We're going to attempt to do some of these problems through video because I want to be able to show you some things. And so then we can talk on the phone and you can ask me any questions, okay? So the video, I'm holding the phone, so it might be a little wobbly, so you're going to have to bear with me, okay? So number 48, so those last three problems, we have number 48. It says using f of x equals x squared as a guide, then describe the transformations and then graph the function right here. So g of x equals the quantity x minus 5 squared plus 2. All right, so a couple of things. First of all, remember that f of x equals x squared, then that's the parent. That's the parent function for a parabola. So right here, I'm going to zoom in. So here is f of x equals x squared graphed right here. Right here is the vertex at the origin, and I have some points here, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and you'll see this is the parent graph, the parabola, okay? So that's what we're going to use as a guide. Now, something else you need to remember, transformations. Transformations, that's just the movement that the graph takes on. So from the parent parabola or function, right, into this function right here, how is it going to move around this x and y axes right here when we rewrite it as this g of x function. So a couple of things to remember. A translation is a slide, and a reflection, that is how it reflects across an axis of symmetry. Okay, so if you think of like your reflection in the mirror. Also rotation, but you're not going to have to worry about rotation with this particular problem. So you might want to write these down on your index card. Okay? All right, so what we want to do here, just a reminder that when a function is written in vertex form, here it is, a function written in vertex form. F of x equals a times the quantity x minus h squared plus k. The vertex is hk. Remember, you take the opposite of that number that's with x in the parentheses. So hk. All right, that's the vertex. And a, that's your coefficient right out here outside of the parentheses. That will determine whether your parabola is opening up or down, what the stretch is, if it's really, really thin and stretching up high, if it's wide, if it's, coming out as a wider bowl. So that A will determine the stretch. So you might want to have this down on your index card too, okay? All right, so if we take a look back at our g of x, and this is what we want to describe, okay? Right here, you don't see a number, a coefficient A, right here in front of the parentheses, so that means there's a 1 there, which means that the stretch stays the same. It's going to open up because it's positive. There's no negative sign there. So a positive 1, it's going to open up with the same type of stretch to it. It won't be compressed. It won't be expanded. But it will have a new vertex. And the vertex here will be at 5, 2. So a positive 5, 2. So we'll come over here, 5, 2. And the new vertex, let's see if I can write this without it wobbling all over the place. The new vertex will be here, okay? And then you're going to open up with the same amount of expansion right here. So we're going to have points there. We'll have points here, so on. So it'll look something very roughly like this. Oh, that's kind of wobbly. All right, so right here, that will be the new one, okay, with the new g of x. So describing right here, describing the transformations, okay, it translated all right, over 5. So 5 in the 5 to the right, and then up 2. And that's the vertex right here. So to the right 5, and then up 2. That was the translation, or that's how much it translated. Reflection, there's no reflection here, because remember our A right here is a positive 1, so it still opens up. And it has the same amount of opening. It's not stretched anymore, not a little bit more narrow. It's not a little bit wider, so it stays the same, but the vertex has changed. With this parabola, since it is opening up, and also with the parent parabola, they do have minimum values. So the vertex here is at a minimum, the vertex is the minimum value. All right. I think that's pretty much it. That's all you had to do with number 48. So you can replay this, and if you have any questions about number 48, then you can ask me. All right? Awesome. And then I'll get the other problems going in just a second. All right.